For decades, we've spoken of the housing crisis. It's a phrase that has become so commonplace, so worn by overuse, that it has almost lost its meaning. But for countless families, it is a stark and unforgiving reality. The dream of a secure home, the dream of an affordable home, the dream of a well-designed home is drifting further out of reach. Cost of materials spiraling, shortage of skilled labor, time to build stretching into an eternity. It's a ponderous industry. It's an expensive industry. It's often wasteful, one that has been stubbornly resistant to revolutionary change. We've been tinkering around the edges, but the fundamental process remains the same. And yet, what if the solution wasn't about tinkering? What if it was about starting again, with a completely different set of tools? We stand at a fascinating precipice, a technology pulled from the pages of science fiction. The idea of printing a house layer by painstaking layer, but it is happening right now. The potential is staggering. So how on earth do you print a house? The term itself can be misleading. We're not talking about a desktop printer spitting out sheets of A4 paper. Instead, think of it as industrial-scale pottery, but with a robot as the potter. The process is known as additive manufacturing. A giant computer-controlled gantry machine follows a digital blueprint with relentless precision. It's a mesmerizing dance of technology and material. The machine extrudes a quick-setting concrete-like mixture from a nozzle. It lays down a continuous bead, one layer at a time, building the walls up from the foundation. This isn't just a solid block of concrete being squeezed out like toothpaste from a tube. The real ingenuity lies in how the walls are structured, hollow, zigzagging, ribbed. This clever design uses significantly less material. It creates natural cavities for insulation. It creates natural cavities for plumbing. It creates natural cavities for electrical wiring. It's an integrated approach to building that considers all the subsequent stages from the very first layer. The software is the architect, and the printer is the tireless builder, executing the plan without deviation, fatigue, or a tea break. It's a remarkable fusion of digital design and physical creation. The material science behind this is just as fascinating as the machinery. The mix has to be perfect. It's a secret sauce, a construction alchemy for the 21st century. Perhaps the most astonishing claim made by the proponents of 3D printing is the sheer, breathtaking speed of construction. Where a traditional build might see a team of bricklayers spend weeks or even months meticulously laying courses to erect the walls of a house, a 3D printer can extrude the entire structural shell in a matter of days, sometimes even in under 24 hours of total print time. This is not a marginal improvement. It is a revolutionary leap. It fundamentally alters the project timeline, condensing a major phase of construction from a season into a weekend. For developers, aid organizations, or anyone facing an urgent need, this acceleration is nothing short of a game changer. This dramatic reduction in build time naturally leads to significant cost savings. Labor is one of the biggest expenses in any construction project. By automating the wall building process, 3D printing drastically reduces the number of workers required on site. You replace a whole team of masons and laborers with a handful of technicians to oversee the machine. Furthermore, the precision of the printer means there is virtually no material waste. Traditional construction is notoriously messy, with offcuts, broken materials, and over-ordering contributing to landfill. A 3D printer, however, uses only the exact amount of material needed to create the structure, placing it precisely where the digital plan dictates. The environmental benefits extend beyond just the reduction of on-site waste. The efficiency of the process can lead to a smaller carbon footprint for the construction phase itself. This reliability removes a significant element of risk and uncertainty from the building process. This isn't just a theoretical exercise. Three-dimensional printed homes are springing up around the world. One of the most compelling examples is in Nacayuca, Mexico. New story, Icon. These homes were designed for families living in extreme poverty, safe, resilient, dignified. The 500-square-foot homes were printed in around 24 hours. 2 bedrooms, a living room, a kitchen, a bathroom. For the families who moved in, this was a life-changing transition from flimsy shacks to secure, permanent homes. In the United States, several companies are pushing the boundaries for the commercial market. In Austin, Texas, Icon has built a series of homes, blending high-tech construction, thoughtful design, elegant curved walls, layered textures, a modern aesthetic. They are sold on the open market, proving demand beyond crisis housing. Europe has also become a hotbed of experimentation. Project Milestone in the Netherlands, Eindhoven's first legally habitable 3D printed house, shaped like a large organic boulder, designed to blend with its natural surroundings, a new architectural language, an honest expression of how the building was made. They serve as living laboratories. For all its dazzling potential, the path to a three-dimensional printed housing revolution is not without its obstacles. Perhaps the most significant hurdle is regulation. Building codes are the bedrock of the construction industry, ensuring safety and quality. They have been developed over centuries for traditional materials and methods like timber frames, brick and mortar. A three-dimensional printed wall, a monolithic structure of layered concrete, doesn't fit neatly into these existing categories. Convincing local authorities, planning departments, and mortgage lenders of the safety, durability, and longevity of these new structures is a slow and painstaking process. Each new project often requires bespoke engineering assessments and approvals, which can stifle the speed that makes the technology so attractive in the first place. Then there is the challenge of the materials themselves. The proprietary concrete mixes used by printing companies are marvels of chemical engineering, but they are also a limitation. The industry is still heavily reliant on cement-based products, which have a significant carbon footprint. While the efficiency of printing reduces the overall amount used, the quest for truly sustainable and green printing materials is paramount. Public perception also plays a crucial role. For many, the idea of a home is deeply intertwined with traditional aesthetics and a sense of craftsmanship. The idea of living inside a printed structure can feel cold, alien, or flimsy. Will people embrace the unique, layered texture of a printed wall, or will they demand it be covered up to mimic a conventional home? Finally, we must acknowledge the current limitations of the technology itself. At present, most companies are only printing the vertical walls. With millions of people living in inadequate housing and vast numbers displaced by conflict, displaced by climate change, the global housing shortage is one of the most daunting challenges of our time. It is in this context that three-dimensional printing's potential shines brightest. The ability to build safe, durable shelters, rapidly, and affordably, could be a transformative tool for humanitarian aid organizations and for governments. Imagine a fleet of printers being deployed to a disaster zone. Printers arrive on site and begin erecting a new village of permanent, resilient homes in weeks, not years. This provides immediate shelter and the stability and dignity a community needs to rebuild. The scalability of the technology is a key factor in this ambition. Unlike traditional construction, it requires only a small team of trained technicians. Contrast that with a large skilled labor force needed for conventional builds. Once the initial investment in machinery is made, the cost per house can be dramatically lower. That makes it attractive for developing nations and for NGOs working with tight budgets. By localizing material production, perhaps even using soil from the building site itself, that can simplify the logistical chain for remote areas. However, we must be cautious. This is not a universal panacea. Simply dropping high-tech printers into complex social and economic environments is not a solution. A successful project must be culturally sensitive and contextually appropriate. Three-dimensional printing could become one of the most powerful instruments we have for safe, adequate housing for all. We find ourselves at a truly remarkable moment in the story of architecture and construction. Three-dimensional printing for housing has moved from the realm of academic theory and futuristic speculation into a tangible, if nascent, reality. The sight of a robotic arm weaving a house into existence is a powerful symbol of human ingenuity. We have seen how this technology promises to build faster, cheaper, and with less waste than the methods we have relied upon for centuries. The pioneers in Mexico, the Netherlands, the United States have laid a foundation, proving that this is not a fleeting gimmick, but a serious and viable construction technique with profound implications for the future. The journey, however, is far from over. As with any disruptive innovation, the initial excitement must be tempered with a healthy dose of realism. The hurdles are significant. Navigating the labyrinth of building codes, developing sustainable and affordable materials beyond cement, and winning the hearts and minds of the public are all grand challenges in their own right. The technology is still in its adolescence, a brilliant specialist that has not yet learned to be a master of all trades. It prints the walls beautifully, but the rest of the house still requires the familiar ballet of different trades and traditional techniques. So, is this the future of housing? The answer, I believe, is a qualified and optimistic yes. It will not replace traditional building overnight, nor should it. There will always be a place for craftsmanship, for the beauty of timber, stone, and brick laid by human hands. But three-dimensional printing presents a powerful new tool in our toolbox, and that in itself is a truly grand design.